Hello everyone, welcome you all to Binju's Education. And today's topic of discussion is data sufficiency, and we'll be solving 5 questions from the inequalities chapter. Now, this is the second video in the series of data sufficiency inequalities. I have already uploaded one video on data sufficiency with inequalities. So this is the first video that you're watching for data sufficiency inequalities. Then after this video, you can go and watch the first video also, right? Because in the first one we discussed like couple of basic questions which will which are actually solvable. And in this video, the questions that we will be taking up are going to be slightly difficult than what we have done in the previous video. All right. Now we'll keep up. We'll basically do it in the same way. I'll be showing you a question on the screen, and you'll be pausing the screen, and then you'll try and solve it by yourself once, and then probably you can play back the video and understand how I have approached the question. All right. All right, and if you're completely new to this chapter inequalities, then I would actually suggest you to go to Business Education SAT plus GRE plus GMAT. Go to the playlist option and look for the inequalities chapter. Okay, go through all the basics of inequality and then come back to this video in order to understand how to solve these questions. All right. All right. So let's get started. Let's move to question number one. So pause the video and try this question, please. All right, let's see how we can solve this one. So the question is D negative? So the actual question that we want to answer to is D less than 0. Okay. And remember one more thing, as I have been telling you this for past many videos, and probably I will be discussing this in the next videos also, that whenever you talk about data sufficiency, remember one thing: you're not looking for an affirmative answer, you're looking for a conclusive answer. Okay, we're not always looking for yes. A no is also a conclusive answer. So whether you have a conclusive yes or you have a conclusive no, both of them works. Okay. All right, let's see what we can do with this one. So it says that e plus d is minus 12. So statement one that I have is e plus d is minus 12. Now, do I know anything about e? No. Do I know anything about d? No. And d is something that I need to actually evaluate, right? So I do not know anything about e. The only thing that I can write here is that d will be equal to minus 12 minus e. Now, if e is greater than or equal to 0, in that case d will always be negative because it's minus 12 minus e. But if in case e is less than 0, then there are like infinite number of cases in which d will become positive. For example, you can, if you take e to be like minus 13, minus 14, minus 15, minus 16, minus 17. So for all these numbers, the value of d will become 1, 2, 3, 4, 5, 6. So the basic point is, unless and until I know anything about e, I won't be able to figure out whether d is negative or not. I do not know that. So statement 1 simply gives me e plus d is minus 12. So I can't conclude anything, which means if I write my options in the chronological order, so we have D, A, B, C, E. So A goes out, D goes out. Okay. Second statement says that E minus D is less than minus 12. So I can like, first of all, let me add 12 on both the sides. So E plus 12 minus D is less than 0. Then let's add D on both the sides. So E plus 12 is less than D, or D is greater than E plus 12. Now again, the point is I do not know the value of E. Like for example, what if E is like minus 100? But what if E is like 1000? What if E is 0? I do not know the value of E. So again, if I do not know the value of E, I cannot comment anything regarding D. So that means option statement 2 alone does not give me a conclusive result. So that means B also goes out. So D is out, A is out, B is out. The only thing we are left to check is the C part. That is when we're going to combine both these statements. Okay. Now, my first equation is E plus D is equal to minus 12. Second is E minus D is less than minus 12. I'm going to write one small piece of information here so that I can make things clear for each one of you. When you write less than minus 12, can I say less than minus 12? I'm going to write like a couple of integer values. So don't think that it's only the integers part which I'm considering. I'm writing integers so that you can develop that thought process of solving the questions of the similar kind. Now it says less than minus 12. So less than minus 12 are numbers like minus 13, minus 14, minus 15, minus 16, and so on and so forth. Like obviously you can have minus 12.5, minus 12.1, minus 12.9, minus 12.00000001 also satisfy this. I've just written integers so that everyone understands what I'm trying to indicate here. All right. So E plus D is equal to minus 12 and E minus D is the result of E minus D are numbers like minus 13, minus 14, minus 15, minus 16 and so on and so forth. Okay. Now let's I need D, right? Because the question is D negative? Now what I'm going to do is I'm going to subtract. So this is my equation number 1, this is my equation number 2. So I'm going to do equation number 1 minus equation number 2 so that the E gets eliminated. Okay. So D minus D, because there is a negative sign because I'm subtracting it. So E minus E is 0. D minus of minus D will become positive 2D. And see, now this is the part where everyone has to be careful. See, this is minus 12. This is, I'm going to write this down here. This is minus 12 minus something less than minus 12. So less than minus 12 is like minus 13, minus 14, minus 15, minus 16, minus 17. So I can say one thing for sure that these numbers, if we talk about their absolute values, if we talk about their absolute values, I can say that these numbers which are like less than minus 12 are actually greater than 12. I'm only talking about the absolute value. Listen to me very carefully. I'm saying the numbers which are less than minus 12, numbers which are less than minus 12, the absolute values of those numbers, the absolute values of those numbers will be greater than 12, because I'm considering numbers like minus 13, minus 14, minus 15, minus 16. So you're going to have like numbers minus 13, minus 14, and so on and so forth. So I can say that the result of this entire thing will always be greater than 0. The result of this entire thing will always be greater than 0. It's something like this. Let me give you an example. What I'm actually doing here is that I'm doing minus 12 minus of minus 13. I'm doing minus 12 minus of minus 14. I'm doing minus 12 minus of minus 12.5. I'm doing minus 12 minus of minus 12.00000. You can write 0 like thousands of times and then 1. All of them will give you value greater than 0, because all the numbers which are written within the bracket, all the numbers which are written within the bracket have a magnitude greater than 12, have a magnitude greater than 12, which means I can say that 2D 2D will always be greater than 0, which means D will always be greater than 0, and hence your answer is option number C. But this was the important part. This was the third process which you need to generate here. All right. All right, guys. So the answer for this question is C. Okay, now let's move on to question number 2. Pause the video and draw this question, please. Okay, let's see what do we have to do here. So n is a non-zero integer. Now non-zero integer means n is like -4, -3, -2. It can be 0, 1, 2, 10, like numbers like these. It says non-zero, it can be okay. My bad, I'm sorry. It says non-zero, it says non-zero. So no, this is like you can have -1 and then 1, 2, and so on. Okay, let me write this properly. My bad. -1, 1, 2, 3, and so on and so forth. So you will not have zero, but you can have negative integers. You can also have positive integers. Now the question is x to the power n less than 1? So is x to the power n less than 1? Now, do I know the value of x? No. Do I know the value of n? No. So couple of things that will actually cross our mind is, let's suppose the value of x is like 4 and value of n is 2. So in this case, this will be greater than 1. What if x is half? And what if n is again 2? This is again less than 1. There are like many permutations and combinations which can happen with this x to the power n. Okay, so let's start. So statement number 1 says x is greater than 1. Okay, fine, x is greater than 1. So we will basically have something greater than 1 to the power n. Now if n is positive, then something greater than 1 raised to the power n will also be positive. It will not positive. I think I'm writing the wrong word here. If n is positive, then something greater than 1 to the power n, it will also be greater than 1. Because anything to the power 0 is 1. Anything to the power, anything, any number, any real number to the power 0 is equal to 1. Or since we are talking about greater than 1, so let's write simply greater than 1 so that you guys don't get confused. So any number greater than 1 to the power 0 is always equal to 1. So any number greater than 1 raised to any power greater than 0, this will always be greater than 1, because now you're increasing power also, right? All right. For example, like if you do 2 to the power, even if you do 2 to the power 1 by 2, no, this is still 1.41. Even if you do cube root of 2, that will also be greater than 1. Even if you do 100th root of 2, that will also be greater than 1. 2 to the power 0 is 1. But if you increase the power, if the power is greater than 0, then 2 to the power anything greater than 0 will always be greater than 1. Okay. So if n is positive, if n is positive, because we're gonna have cases, it simply says x is greater than 1. X greater than 1 does not define everything. If n is positive, then greater than 1 to the power n is always greater than 1. But if n is negative, then greater than 1 to the power n will actually be between 0 and 1. Like for example, if you do 2 to the power minus 1, this will be 1 by 2. If you do 2 to the power minus 2, then it will be 1 by 4. If you do 2 to the power minus 3, it will be 1 by 8. So even if like you have a number which is greater than 1 in the base, but if the power is negative, then the overall value will actually be between 0 and 1. So can I have a definite conclusion from here? Is it possible for me to have a definite conclusion? Can I for sure say that x to the power n is greater than 1 or less than 1? No, I can't say that. Simply defining the base will not give me a definite conclusion whether the result is greater than 1 or less than 1. So if I write D, A, B, C, E, D goes out, A goes out. Okay. So now let me wrap this off because I need space for statement number 2 now. Okay, now statement number 2 is n is greater than 0. Okay, fine, n is greater than 0. So n is like 1, 2, 3, 4, whatever the number is. But do we know the value of x? Again, we do not know the value of x. So it may happen that you have like x is half. So you have half to the power 1, which is less than 1. What if x is 2? 2 to the power 1 is 2, which is greater than 1. Right? So in fact, you can even have x is equal to 1. So 1 to the power anything, because n is greater than 0. So 1 to the power anything will always give you 1. So again, do you have a definite conclusion? No, you don't have a definite conclusion. Because again, you do not know, in this case, you do not know the base. In the first case, we did not know the power. So B also goes out, which means the next option is C. Let's combine both of them. You have something greater than 1 and you have a power greater than 0. Now, I just told you that if you have a number, whatever number you may have, or let's only talk about greater than 1 because otherwise you guys are going to get confused. If you take a number greater than 1 and if you raise it to the power 0, then the result is always equal to 1. Any number raised to the power 0 is 1. Now, if I'm going to increase the power, because now the power is greater than 0, can I say my result should also be greater than 1? Because when the power was 0, then my result was 1. Now I'm increasing the power also. So my result has to be greater than 1 no matter what happens. Like even if you do the like 100th root of 2, you'll find that this value is also greater than 1. You can't do that manually. You'll have to use a calculator, a scientific calculator, or a graphing calculator. So you'll still find that the value is greater than 1. Okay. All right. So if we combine both of them, then this is the definite conclusion that we have, that any number greater than 1 raised to the power greater than 0 will always give you a result greater than 1. So the question is x to the power n less than 1? So answer is no. Is no conclusive? Yes. Hence the answer is again C. Hence the answer is again C. Okay. All right. Pause the video and draw this question, please. Okay. So let's see what do we have in this. Is x cube greater than 1? Okay. So we need x cube greater than 1. Okay. So x cube greater than 1. So a couple of things that we can conclude from here is that the value of x has to be greater than 1. Now, why did I arrive at this conclusion? Understand. Okay. First of all, x can't be negative. I think everyone would agree with that. Because if you do cube of negative, the result is also negative. Second is x can't be 0 because cube of 0 is 0. Now the only numbers that we are left with are numbers between 0 and 1, like 1 half, 1/8, 1/4. So take a couple of examples, like if I do half cube, or if I do 1/4 cube, or if I do cube of 1/8, all these numbers will definitely be less than 1, right? Because they're fractions and you're like cubing them, right? You're multiplying fractions with themselves, so you can't cross 1. It's not possible. So x cube greater than 1 basically means that you're looking for x greater than 1. This is what you need to understand first of all. If you have understood this, then the question won't be that difficult. Okay, so we are actually trying to find out, is the value of x greater than 1? Okay, all right. Let's see what the first statement has to say. It says that x is greater than -2. Now, if x is greater than -2, let me draw that on a number line. We have -2 here. It says greater than -2. I'm going to put circle here. This is what it says. Now, if it is greater than minus 2, is it necessary for x to be greater than 1? No. X can be minus 1 also. X can be 0 also. X can be half, 1/8, minus 1.5. All these numbers are also possible. Because the first statement says x is greater than minus 2. Greater than minus 2 does not necessarily means that it will be greater than 1. So do I have a conclusive answer from statement 1? No. Like if a number is greater than minus 2, it can be greater than 1. It can actually be 1 also. But it can be less than 1 also. All three are applicable. All three are applicable. Okay. So again, I'm going to write D, A, B, C, E. So D goes out, A goes out. Second statement, 2x minus of B minus C is less than C minus B minus 2. So 2x minus B plus C is less than C minus B plus 2. So I can subtract C on both the sides, then I can add B on both the sides, everything is going to get cancelled, and you will have 2x is less than 2, which means x is less than. From the second statement, we are getting x is less than 1. So do we have a conclusive answer? Yes, we do have a conclusive answer. Question is x greater than 1? The answer is no. Using second statement, we can simply say the answer is no. Is no a conclusive answer? Yes, it is a conclusive answer, which means answer is B. Alright, let's move on to question number 4. Pause the video and try this question, please. Okay, so is x greater than 10 to the power 10? Okay, first statement is x greater than 2 to the power 34. Second is x is equal to 2 to the power 35. All right, okay. Now, what I will be doing if I have this question in my exam, I would realize one thing for sure, that is my answer cannot be C. Okay, now how did I arrive at this conclusion? Understand. Read these two statements carefully. The first one says that x is greater than 2 to the power 34. Second one gives that x is equal to 2 to the power 35. Which means the only common part the two statements have is actually 2 to the power 35. And if 2 to the power 35 gives me a conclusive answer, if 2 to the power 35 gives me a conclusive answer, then my answer will simply be option B. Because according to the chronological order, my order is D, A, B, C and D. If 2 to the power 35 is giving me a conclusive answer, I'll simply say my answer is B. I don't have to even go to C. Because you will combine both the statements when statements individually are not sufficient to answer the question. You will only combine these statements when the two statements individually are not sufficient to answer the question. Right? So the common part is 2 to the power 35, which is actually statement 2. So one thing is for sure that C cannot be my answer. Either it will be D or A or B or E. And I don't think E can also be the answer, because this 2 to the power 35 will be greater than 10 to the power 10, or it will be less than 10 to the power 10, or effectively equal to 10 to the power 10. Whatever it will be, you will have a conclusive answer. Okay, now I'm not even solving this. See, I'm simply using my logic, I'm simply using my head. This number 2 to the power 35, it will either be equal to 10 to the power 10, it will either be greater than 10 to the power 10, or it will either be less than 10 to the power 10. It cannot be two of them. It cannot be two of them at a given point of time. It's not possible, because these are like numbers. A number will be greater than another number, equal to another number, or less than another number. So no matter what happens, 2 to the power 35 will always give me a conclusive answer. right? You don't even have to solve this if you understand this question. Okay, but anyways, we will be solving this. Let's try and understand. Now, I have realized one thing, that C will be not my answer, so I have to actually look upon these two statements individually. Let's see what we can do. So I'm going to start with statement number 2 so that you also understand statement number 1. Okay, or okay, fine. Let's start with statement number 2 so that you understand how to solve questions like this. Okay, so I'm going to keep 10 to the power 10 on one side, and I'm going to have 2 to the power 35 on the other side. So this is 2 into 5 to the power 10 and 2 to the power 35. So 2 to the power 10, 5 to the power 10, 2 to the power 35, 5 to the power 10, 2 to the power 25. I have basically cancelled out 2 to the power 10 on both the sides because those two are equal, so they won't make a difference. Okay. Now look at the powers. How do you solve this further from here? This is the important part. Look at the powers. This is 5 to the power 10. This is 2 to the power 25. The bases are not equal. Neither I can make them equal, right? Because in the power of 2, you will never have 5. In the power of 5, you will never have any power of 2. Now, this 10 is nothing but 2 into 5. This 25 is nothing but 5 into 5. So, can I rewrite this as 5 square whole to the power 5 and this as 2 to the power 5 whole to the power 5? I've made the powers equal. If you want to compare exponents, there are only two things which you can do. Either make the bases equal or make the powers equal. Either make the bases equal or make the powers equal. Now, if in case, let's suppose you have a to the power b and c to the power d, a is greater than c and b is greater than d, then I think there is no discussion for that. But if in case one of the smaller base has the bigger power, in that case you will have to make one of them equal. If the smaller base has a bigger power, if the smaller base has the bigger power, then in order to compare two exponents, you either need to make the bases equal or you either need to make the powers equal. You have to do either of the two. That is required. All right. So in this case, we can't make the bases equal because no power of 5 will be equal to any power of 2. It's not possible. 5 is like 5, 25, 125, 625. 2 is like 2, 4, 8, 16, 32, 64. So what I can do is I can simply make the powers equal. That's the only option with me. So it's 5 square to the power 5. That is basically 25 to the power 5. This is 2 to the power 5, which is 32 to the power 5. Now which of them is greater? Obviously 32 to the power 5 is greater. So one thing is for sure, that this number is greater than 10 to the power. This number, because if this is x, then this is definitely greater than 10 to the power 10. So B will definitely be my option, no matter what happens. So if B is my answer, then C goes out and E also goes out. Now it's either D or B. It's either D or B. Now, if the first statement is x is greater than 2 to the power 34, let's do one thing. Let's compare 10 to the power 10 with 2 to the power 34. If 2 to the power 34, if 2 to the power 34 is greater than 10 to the power 10, if we are able to prove that 2 to the power 34 is greater than 10 to the power 10, then of course anything greater than 2 to the power 34 will always be greater than 10 to the power 10. But if 2 to the power 34 is less than 10 to the power 10, then we will be in dilemma. Because unlike statement 2, statement 1 has an inequality sign. It does not have an equality sign. Otherwise, actually, frankly speaking, you don't even have to solve the equation if statement 1 also had an equality sign. Because again, use the same concept. 2 to the power 34 will either be greater than 10 to the power 10 or less than 10 to the power 10 or equal to 10 to the power 10. It has to be only one of the three, right? But if you have an inequality sign, then there are like a lot of possibilities. Anyways, let's try to solve this. So this will become 2 to the power 10 into 5 to the power 10, and this is like 2 to the power 34. So this is 5 to the power 10 and this is like 2 to the power 20. So 10 is like 2 into 5, and this is like 2 into 12. So this is 5 to the power 5 whole square, and this is like 2 to the power 12 whole square. So 5, 25, 125, 625, 3125, 5 to the power 5 is 3125 square. Now 2 to the power, okay, let's do 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048 and 4096. Just 4096 to the power. Which of them is greater? 2 to the power 34 is greater. Now if 2 to the power 34 itself is greater, if 2 to the power 34 itself is greater, then of course any number greater than 2 to the power 34 will always be greater than 10 to the power 10. Hence our answer is option number. Now you could have made this question even smaller. You could have made this question even smaller. You would be like, okay, B has to be my answer. I don't have to even worry about B. B will definitely give me an answer. And it will give me a conclusive answer. Whether yes or no, I don't care, but it will give me a conclusive answer. What I could have done is, I could have simply compared 10 to the power 10 with 2 to the power 30. If 2 to the power 34 is greater than 10 to the power 10, if 2 to the power 34 is greater than 10 to the power 10, then 2 to the power 35 will automatically be greater than 10 to the power 10. Even though I'm not looking for an affirmative answer, but again, you would have an affirmative as well as a conclusive answer. Okay, so these are like small things. I know it's difficult when you're sitting in the exam, but if these things actually click, no, they will actually save a lot of amount of time. All right, let's move on to the next question. Let's try question number 5. Okay, pause the video and try this question, please, guys. All right, let's try this one. Is x a negative number? Okay, x is a negative number, so we are trying to find out if x is less than 0. X square is a positive number, so my first statement is x square is greater than 0. Now if x square is greater than 0, then x can be negative, x can be positive also. But one thing is for sure, that x is not 0. This is the only thing that we can conclude. X is not 0. X can be positive, x can be negative, because negative square is also positive and positive square is of course positive. Okay, all right. So do we have a conclusive answer? No, we don't have a conclusive answer. So if we write D, A, B, C, E, so A goes out, D goes out. Second is X mod Y is not a positive, is not positive, which means X mod Y has to be negative. If X mod Y is not positive, which means X mod Y has to be negative. Now, when you talk about modulus, remember that result of modulus is always greater than or equal to 0. Now it can't be equal to 0 because the product is less than 0. So mod of y will be positive and x will be negative. So you'll just quickly jump to the conclusion that the answer is B, and this is where this is exactly where you are wrong. This is exactly where you are wrong. Understand the statement carefully. It's saying it's not a positive number. It's not a positive does not mean that the result is negative. The result is negative or the result is 0. or the result is 0, or the result is 0. So if you do x mod y is less than 0, if we look at this first case, when x mod y is less than 0, in that case one thing is for sure, that x has to be negative. What about y? Y can be positive, y can be negative, it can be either of the two. Yeah, but y can't be 0 also. This is another conclusion. In the second one, x mod y is equal to 0. In that case, you can have x equal to 0, you can have y equal to 0, or you can have both xy equal to 0. You can have both xy equal to 0. So from these two conclusions, that is from statement 2, we got two conclusions. So x can be negative, x can be 0 also. So the question is x a negative number? So do we know that for sure? No. No, 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 no. Okay. Now, before we actually move on with this question, I have a question here, and let me know the answer of that question in the comment box. Let's say for some condition, let's say for some condition, from statement 1, we would have got the conclusion that x is positive, y can be positive, y can be negative. And from statement 2, we got the exactly the same conclusion, that either x is 0 or y is 0, or both of them are 0. Okay, just one slight changes. Instead that x has to be negative, I got the conclusion that x is positive. Let's say for some other question, the question is still, is x a negative number? So my question is it possible for us to give a conclusive answer using the second statement? Is it possible for us to give a conclusive answer from the second statement alone? Okay, so this is the question. Try to think about this and let me know in the comment box. Anyways, coming back to the question. So from the second statement again, you don't have a conclusive answer, which means B also goes out. Which means B also goes out. Now, if I combine both of them, so in this case, x is negative or positive. Here we have x is negative or x is 0. So the common part is when they are negative. The common part is when they are negative. So when you combine both of them, then the common conclusion regarding x is that x is less than 0. So is x a negative number? So your answer is yes. X is a negative number, or basically you have a conclusive answer, which means your answer is again option number C. Okay. So these are like another 5 questions from this topic, inequalities. Thank you so much, guys. Keep watching and keep learning. If you have any questions, any concerns, any queries, do let us know in the comment box, or you can mail us your concerns, queries, or you can also WhatsApp us. Okay. Don't forget to subscribe the channel for more videos and exams related content on SAT, GMAT, and GRE, and do follow us on our Facebook page also for more content. Okay. If you're looking for personalized classes, then you can always connect with us. All right. Okay, guys. Thank you so much. Keep watching and keep learning.